So I'd just like to introduce Frank McKenna, who many of you may know years ago developed the open system for earthquake engineering simulation. And with the SimCenter, he's been the architect for our kind of software framework and managing a team of postdocs. So I'd like to welcome Frank.
Thanks, Greg. So I won't introduce myself. Let me just give the title of this presentation. It's the overview of the NHERI SimCenter. Before I begin, let me quickly set a context for where SimCenter is within NHERI. NHERI itself, as many of you might know, is 12 facilities. The facilities is headed by the NCO, which does a collaboration between the sites. We have 7 experimental facilities, of which the Wall of Wind is one. There are 2 recon facilities. All the data for the experimental facilities and the recon facilities basically goes to the site called DesignSafe, which basically hosts large databases which allow people to access the data. DesignSafe also provides HPC resources, and they provide a lot of applications, for example, OpenFOAM, that run on those resources that they make available to the community. SimCenter, we're actually a virtual experimental facility. Our facilities, we have like 7 or 8 computers. That's the extent of our hardware facilities. But we produce software. That software we make available on DesignSafe, and the software through DesignSafe for interfacing with our tools directly, they impact researchers, industry, and government agencies. That's ultimately what our software tools are aimed at, helping researchers, industry, and government agencies work in natural hazards. Our goal, the goal we set is we want to transform the nation's ability to understand and mitigate the effects of natural hazards. Basically, this is going to be done through computational simulation. We like to say it's grounded in the present. It has a 5-year focus, the length of our project, but really is a 20-year vision. So what the mandate from NSF? They want us to produce software that researchers are going to use in their research. To do this, we're developing an open source computational framework. That framework is for building what are called scientific workflow application systems, and these systems must deal with uncertainty quantification. To do this, we're designing the framework so that it's flexible, extensible, and scalable, so that researchers other than ourselves can add to that framework by extending to it. Finally, we're also seeding the framework with components, data, and interfaces. And then we're releasing tools built using this framework so that engineers can start using it now, researchers can start using our applications now. And hopefully through our software and the way we're educating the users in our community on this software, we're hoping to build an ecosystem which fosters collaboration between the different researchers, industry, and those in government agencies. So before I get too much further, let's go over what a scientific workflow system is. This is an application that allows users to build and launch and monitor what are called scientific workflows. On the right is the definition of a scientific workflow. Let me just go through it graphically with this image on the left, this jigsaw image. These jigsaw pieces they're all different applications. So when somebody's running a scientific workflow, they're basically running a bunch of different applications. And what's running this applications is software, and that software is starting applications, providing the input to the applications, taking the output from one application and then passing it to another application. So the software manages the invocation of all the different applications in the workflow. And what the scientific workflow system does, it allows users to pick and choose which of the applications to use for the different pieces in the puzzle. And of course, we're not starting from scratch. We're not developing totally new applications. We're trying to use as much existing applications as we can. To do this, we're basically writing pre and post processors, and we're defining interfaces that the applications must meet. So our tools execute workflows, and what's really different about our workflows is that they produce UQ at the end. We're not interested in single response quantities. We want to know, say, for example, the mean and the standard deviation of a response quantity. To do this, we're using either the user's desktop, which there are multiple cores on the desktop, or again, For large-scale simulations, for running many samples, we're having to use the resources. We're allowing the users to use the resources at DesignSafe. For example, the Stampede 2 high-performance computer. And pretty soon people will be running their simulations on Frontera, which right now is the 8th fastest supercomputer in the world. So the software, we've released 4 applications right now: PBE, Euq, EEUQ, and QuoFem. So these are the examples of the software that we're releasing. As I mentioned, these software are built using components. These are basically showing the different components and how the individual software pieces are built using the different components. And as I mentioned, we're using a lot of existing applications if we can. For example, OpenFOAM, GeoClaw, and AdCirc. So our applications are just interfacing to these existing applications and running them. So currently we have released 4 research applications. These applications are all for quantifying the effect of what's happening to an individual building. Euq, the one I'll talk about tomorrow, I won't talk about too much today, but basically it's looking at the building response for buildings subjected to wind. These simulations are doing either elastic or nonlinear time history analysis. And what really the tool is focused on is actually getting the wind loads. What are the different types? Where can we get the wind loading acting on the building? And here I'm showing basically the different puzzle pieces that go into EUQ. And as I say, to mention, the focus is on the events. What are the different types of events that we can bring into EUQ? And again, I will talk about these tomorrow, so I won't mention them now. QuoFem is another very useful application, particularly for those doing finite element simulations. The intent is to bring EUQ methods to different finite element applications. The different types of EUQ we want to bring in are sampling, sensitivity, reliability, parameter estimation, and Bayesian calibration. Right now we're using a package called Dakota, which provides a lot of these methods, and we're now extending to use other packages and our own built-in code for some of the methods which Dakota doesn't really suit civil engineering. Other applications you're not too probably interested in. We were one for responsive buildings subjected to earthquakes, and our performance-based application, which determines the downtime and loss associated with an event, is currently limited to earthquakes, but hopefully by the end of this year, we'll extend it to include performance-based wind engineering. So the upcoming software, let me focus on two things. We have RDT. This is our tool for doing regional scale simulation. And also we're focused also for RDT, down here on the right, we have the Brails and our database for the building inventory. We can't do regional simulations without knowing what the actual building stock is. And this is where a lot of our focus is in the SimCenter right now, using AI to come up with the building inventory. So as mentioned, the RDT, it's going to be doing for the allowing users to do regional simulation. How it's built, basically there's going to be a front-end desktop application, but all the work is going to be done at DesignSafe using our RWhale application and our Brails. Brails is what's actually building our building inventory. And Tracy later today is going to be talking about both RWhale and Brails, so I won't mention it. The damage and loss part, that's been done by Pelican, and Adam tomorrow will be talking about Pelican. So this is a quick slide to show you sort of how we're using AI. We're using multiple different AI approaches to get the building inventory. This is just one example of how we get the different information about the buildings. There are other approaches. Tracy will talk about those tomorrow a bit, or later today. And I mentioned community building. So we're hoping to build this community around simulation. To do that, we're holding workshops. We've got tool training events. We have a programming bootcamp, which I'm about to leave this meeting and start that programming bootcamp. We release educational applications. And of course, there's our state-of-the-art report that's edited by Greg, which provides information on different approaches for the different hazards. And of course, our test beds, we view the test beds as a really way for the community to gather around and get interested in what SimCenter is doing. And of course, your feedback is needed for all our tools. When we were figuring out what our tools would do, we presented NSF with a list of things we would implement in our tools. We pretty much implemented everything we've been asked for. And now we need, for future features that go into our tool, we do need the community to provide input on what goes into these tools. So we're asking you to go to our message board and provide your input there. So in closure, this is relatively a new project. We're just coming now to the end of our 4th year. We're still in the middle of our 3rd year. All the software we produce is open source, including our building inventories. The source code is made available on GitHub, and our building inventory is made available through DesignSafe. The center is open for collaboration. We're looking to facilitate research. And we encourage you to follow us on Twitter and Facebook. And of course, we really need contributions. We encourage the research community to help in our efforts. So with that, I'm finished. Right on time.
Okay, well, thanks, Frank. This is Greg. I guess, like I say, if folks have any questions, you're welcome to put them on the chat board and we'll respond to them. I did want to mention one thing on Frank. On one of your slides, you mentioned Tracy Kajewski-Correa. I think your slide said her talk is at 10 a.m. today. I think it's at 11:40. This is California time. But anyway, it will be a little bit later this morning. Let's see, we're going to switch over to hear a little bit about the Wall of Wind facility. So Rindan.